Please Look Up is recorded in the Scitech Planetarium on Whadjuk Noongar land. Good evening, everybody, and welcome to the first episode of the brand new podcast, Please Look Up, presented by Particle. In this podcast, we take you on a journey through the night sky of Perth. My name is Leon, and in each episode, I'll be inviting a guest expert to join me for a casual chat about all the incredible things in the night sky, as well as a deep dive on some special topics. This podcast is best listened to outside with your headphones in, and before you go outside, make sure you put a jacket on if it's cold and some bug spray as well. And this week we are joined by an expert from the Scitech Planetarium. Damon, thank you for joining us.
Oh, thank you very much. Expert is a very generous term, I would say, but nevertheless, I appreciate that very much.
Well, we're going to call upon your expertise now because I want to pick your brain about the night sky in March. If I'm just a casual observer outside, looking at the sky after sunset, what sort of planets can I expect to see in March?
Well, in March at the moment, I wish I could tell you that there were a whole host of planets, but your options are actually fairly limited at the moment. Now, if you look in the west at sunset, well, then you might actually see a few, namely Venus and Jupiter. Now, Venus is the much brighter one, and I'm afraid that Jupiter's going to be gone by the end of the month, so catch it while you can. Now, they're the ones that you're going to really notice as a casual observer, but if you want to look really closely, then you might be able to spot just a few more. Uranus, it turns out, one of our favorite planets here in the planetarium, especially amongst school kids, it's in the background as well. And if you have a smartphone, which is most people these days, you can probably use a planetarium app to help you find it. And in the northwest, during the evenings, there is one other planet, and it happens to be objectively the best planet other than Earth. And that planet's name is Mars, the red planet. And very exciting thing about Mars, not just that you can see it in the sky if you look very, very closely, but if humans were to ever travel to another planet, well, Mars, it's probably going to be the first one that we go to.
There you go. I'm going to pick your brain on that later. But just to double check, so you said Venus and Jupiter after sunset.
After sunset.
In which direction, sorry?
You should be looking in the west just after sunset. And remember, brighter one, that's going to be Venus in this situation.
So why is Venus brighter than Jupiter, even though Jupiter's bigger?
Well, Jupiter is bigger, but my friend, Jupiter is much, much farther away. Venus, much, much closer. It's actually the closest planet. Unfortunately, it's just not that great a situation for humans. So if we're going to go anywhere, that's why we're probably going to Mars.
Excellent. I see we've got a passion there. And Uranus is in the background. Can you see Uranus or Uranus without a telescope?
Look, that is an excellent question. I don't think you're going to be in that situation this month.
Oh, and that's why you need the smartphone with your app to help you.
Yes, and even then it's probably going to be quite a challenge. Your main ones to go to are Venus and Jupiter.
Fantastic. All right, so Venus, Jupiter, and Mars, and maybe if you're lucky, Uranus. What about interesting constellations? Just stars. What should I be looking for?
Look, if you're someone who does like to look for constellations, then probably the most famous one that you can see at the moment is Orion. Now, most people, they have an easier time finding Orion, mainly through Orion's belt. You have 3 stars relatively close together in a straight line. And from there, you can build out and you look further and you can find things like Orion's club.
Oh, yes, the hunting club?
Yes, Orion, of course, the famed hunter from Greek mythology.
Which direction am I looking to see that?
If you want to find Orion at the moment, well, I'm afraid you're going to have to be looking in the northwest of the sky. Which, depending on when you do that, easier than other times.
Oh, you said that's where Mars is as well, right?
Yes.
Oh, so I should see Mars and Orion up in the northwest.
Hopefully. Obviously, Perth, it can give you some interesting night skies sometimes, and you're not always going to see everything you'd like to because there are clouds in the way from time to time.
So, all right, so I know that I'm going to be outside looking at the planets, and I'm also going to try and catch a glimpse of Orion. I suppose more generally, Damon, is there any other interesting events or space news that's happening in March?
Well, coming up very soon on the 21st of March, we're actually approaching the autumn equinox. Now, some of you might be familiar with the summer solstice or the winter solstice. They are the days in summer. It's the longest day of the year. In winter, it is the shortest day. The equinox, it's actually the point in between. It's the point where the amount of daytime and the amount of nighttime, they're actually equal.
When you say equal amounts of day and night, for who?
Equal amounts of day and night for every single person on the planet. It's the point where the sun pretty much appears to go directly over the equator during the day.
Oh, okay. So everyone on Earth.
Everyone on Earth, we're all in the same boat as far as daytime and nighttime on this day.
On this day. There you go. Oh, and because we're heading towards winter, I guess after that means we will get less daylight than nighttime.
Yes, because ultimately we'll be approaching the winter solstice. So our days will get shorter and shorter until we hit that point. They'll start to get longer and longer and longer.
Ah, okay. That makes perfect sense. All right, I've learned something from that. All right, well, so that's the night sky sorted. That's the planets. Is there any other interesting space news happening during March?
Well, here at Scitech, there's something that we like quite a bit.
Okay.
And that is 3D printing. It's actually a technology that's been developing in leaps and bounds over the last few decades. And we're actually up to the point now as a species where we can 3D print many of the components that make up a rocket.
Wow, really? I've heard rumors about this. Like when you say many, how much?
So we're looking at, in some cases, up to 80%, maybe slightly more of a rocket. And with some very novel metal fabrication printing techniques, we're actually looking at a situation where some companies that are really pushing the limits at the moment are actually able to print their rocket engines themselves.
Wow. So I've got a 3D printer at home that, I can print toys and things with. You're talking about printing entire rocket engines.
We are talking about printing entire rocket engines. We're talking about printing engines capable of dealing with incredible pressures and temperatures. Your little printer at home, it's probably dealing in PLA plastic.
Yes, it is.
So that one is probably going to melt the moment it may not even hold up to the pressure of the various fuels going through the lines. I'm afraid it's just not up to the standard. What we are talking about is some of the most complicated pieces of 3D printing equipment ever built. But every year that goes by, as they use this technology more and more, hopefully the cost is going to come down further and further. Maybe another 10, 20 years we can have one in our homes. But
that'd be nice. And which company is building these rockets?
So this launch in particular that we are looking at this month, it's a rocket called Terran 1, and it's actually built by a company called Relativity Space.
Relativity Space, okay.
Yes. Now, the two people who founded this company, they did actually work previously for another aerospace company called Blue Origin, which some of you may know was started by Amazon founder Jeff Bezos quite a while ago.
Mm-hmm.
But they've used the expertise that they built up working there for quite a time to now go off and start their own company. And it may be that they actually put something in orbit before Blue Origin does, which would be quite an interesting turn of events.
So are they launching this month or are they trying to launch?
Well, with most things in space, try is the key word.
Right.
So they have recently made an attempt to launch. They did have to abort fairly late into the situation.
Oh, no.
And there is every chance that that happens again because, as we so often say, space is very, very hard. But at the same time, you want to make sure you get everything right because you're talking about having millions and millions of dollars on the pad. And if something goes wrong, that's millions and millions of dollars that's just going to explode and burn up.
Absolutely. So it's worth it to cancel now if there's a small risk than to just roll the dice.
Absolutely. It doesn't make a lot of business sense, especially if you're trying to prove to potential customers that your rocket is reliable.
Oh, and it blows up on the pad.
And it blows up on the pad. I'm afraid that's not a good situation. Relativity Space are hoping in the long term that they'll be able to launch about 1.5 tons to low Earth orbit for the cost of about $12 million, which, depending on your particular customer, maybe universities and things like that, might actually be quite a competitive rate because they wouldn't have to pay $100 million for a rocket that's going to launch a lot more if they don't actually need a lot more.
Yeah, absolutely. And that is the way satellites are trending, isn't it? Much smaller and simpler these days.
Yeah, well, you can chalk a lot of that up to the price reduction in just computing and electronics components that have happened in the last 40 years. Things that you would normally need massive amounts of equipment for mass-wise is now can be done on tiny little things. Just look at a smartwatch. For those of you listening along, I'm looking at my smartwatch right now, just 10 years ago. The sort of things that you can see now on my watch, you couldn't imagine occurring on a device this small. And with a battery life that lasts for more than a day sometimes, things are changing very, very quickly. And so often we don't even notice.
There you go. So I want to pick you up on that point where you said that spacecraft are getting smaller. And as a result, rockets are getting smaller and can still be competitive even though they don't launch tens of tons of equipment. I want to take you to the other end of the spectrum. This is something I know that you're quite passionate about, and that's the SpaceX Starship, which is just a monster in every facet. Can you tell us a bit about what is the SpaceX Starship?
Well, the SpaceX Starship, to put it simple, if it launches, will be the single largest and most powerful rocket ever launched in the history of our species. It stands at 120 meters tall. Now, this is 10 meters taller than the Apollo Saturn V.
Taller than the moon rocket.
Yes. Now, it is a two-stage vehicle. So for those of you listening along, you may be familiar when a rocket launches, as the fuel is used up in a lower stage, it falls away, it comes down. So this is a vehicle that separates into two pieces.
Mm-hmm.
Now, very important about that first stage, it's about 70 meters tall. When that has used up its fuel, it'll fall away. But traditionally, rockets, they fall into the ocean, they get destroyed on impact.
Yeah, they're single use only.
Single-use rockets, not particularly good for the environment, but if you're a company, not particularly good for your bottom line either. Well, this first stage, it's called Super Heavy. It aims to actually come back to its launch site with a small amount of fuel left over, and when it gets there, it will actually come back down onto the pad from which it launched.
So that's what SpaceX have been doing with the Falcon 9 already.
They have, but the Falcon 9, it carries its own landing legs. Now, when we launch into space, every bit of equipment that we put on the rocket, it adds more mass to the vehicle. And what that does is it reduces the amount that we can actually put into space. So the thing that's happening with Super Heavy when it comes back is it doesn't actually have landing legs. It is actually going to be using equipment on the launch tower itself. They refer to them as chopsticks. They're these two massive vertical metal arms that stick out to the side. Now, Super Heavy, it's going to be coming down vertically at a great rate of knots. Imagine a pencil falling out of the sky, but this pencil has rocket engines. And at the last moment, it's going to fire them up and it's going to slow them down. It's going to slow down until the point where it's effectively hovering in the air, right next to the launch tower. And at this point, the two massive chopsticks are going to swing in from the side, hook under some special hooks, and hopefully the rocket will settle right back in place on its launch pad.
They just snatch it out of the air.
Just out of the air like that.
And they put it back on the launch pad and fuel it up and off it goes
Fuel
again?
it back up, check it out, make sure everything's ready to go, and put another Starship on top of that. Because so far, we've only got through the first stage. There's that second stage, it's going to continue all the way into orbit. It's going to be going around the planet so fast, it does one complete circle every 90 minutes. But to get to that velocity, it will actually use up most of its fuel. And so that's why Super Heavy comes back and you put another Starship on top of that. And you launch that one as well. And those two, they go up and they meet. And one of them takes all the fuel from the other one.
Oh, so refueling Starship in space.
Refueling Starship in space with another Starship. And this brings us to the next point.
Yeah, my question, I think, might be the one you're leading up to. Why? Why are we doing this?
Why are we doing this? Well, it comes down to the end goal that Starship was designed for, which ultimately is not about business. It's about exploration. It's about pushing the frontier and going to other worlds. The ultimate goal of Starship is to travel across space to the red planet Mars.
I had a feeling that was going to be the case.
Yes. So ultimately, Starship is a vehicle designed completely around taking human beings back and forth to Mars. So in and of itself, it's meant to be reusable. It can enter both the atmosphere of Mars and of Earth and land without needing to go through extensive repairs, renovations, anything like that. But also, the actual fuel it uses is interesting. See, SpaceX over the last decade, they've been pioneering rocket engines that use methane and oxygen as their main fuel.
Right. What do other rocket engines use? What did the Saturn V use?
So most rocket engines, especially those launched by NASA, they've traditionally used a mix of liquid hydrogen and liquid oxygen. And that technology was developed quite well. SpaceX have had to spend a lot of money and a lot of time, and it's caused quite a few explosions trying to develop these new sorts of engines. And the reason for that is because methane you can actually synthesize from the atmosphere on Mars. Because when Starship ultimately lands on Mars, if that happens, it's going to do so, it's going to come down, and it's probably going to be mostly out of fuel.
It's going to have no fuel left.
But it will have a plant on board that can actually synthesize the fuel. And hopefully over time, over the months, the years that the Starship would be sitting on the surface of Mars until Earth is in the right spot to come back, it will actually be able to fill up its fuel tanks. And this is not some out there chemistry experiment. This has actually been done since the 1800s. It used to be used to actually generate fuel to power gas lanterns in city streets, especially in places like London. It's a well-established technology and hopefully something that we can now apply to space.
Really?
Really?
Gas lanterns?
Yes.
I didn't know that.
Yes, no, it's something called the Sabatier reaction, I'm pretty sure. So you can go look at that one at home on Wikipedia. And this has actually been tested a few times. It's been tested as far back as the late 1980s. A group of aerospace engineers consulting for NASA did actually build a plant that was capable of doing this. And it's the sort of thing that would have actually fit on a Mars mission.
Right. So Starship is literally going to suck in the air of Mars, the atmosphere, apply a bunch of well-understood chemistry to it, and turn that into rocket fuel
Exactly
to come back
right.
home. Because, I guess that's always been the question when people talk about Mars missions is it's always been referred to as a one-way trip that people would be spending the rest of their lives on Mars. But if this technology can demonstrate that it's capable of returning, then suddenly it's no longer a one-way
No,
mission.
it's not a one-way mission at all. Obviously, it is a risky mission and it is a long mission. For those of you listening at home, you have to imagine all the planets are going around the sun and they each take slightly different amount of times to go around the sun. And so what that means is that if you leave Earth in the perfect position to go to Mars, by the time you actually get to Mars, Earth and Mars will have moved really, really far apart. Now, those astronauts, if they go, they'll be moving through space for about 6 months before they get there.
So if you're going to be living on Mars for a year and a half, that's obviously, you're going to need a lot of equipment and supplies and things like that to keep you going. Is Starship going to carry all of that? How much can Starship carry?
The current predictions are that Starship will be able to launch about 150 tons to low Earth orbit. So that'll be your starting situation. That 150 tons, it's going to be taken up by a lot of things. Various equipment, as you say, supplies for breathing on the way, food for the entire journey, all sorts of other things. But we also have to constantly launch the Starships up and meet with the other one to refuel it. And once we do that, we'll probably find that the actual vehicle that travels to Mars is going to weigh more than 150 tons. But we can only do that by doing multiple launches.
Yep, absolutely. So this all sounds like a really fantastic long-term ambition, and probably the most plausible out of all of the proposed Mars missions that have happened over the years. How far along this process are SpaceX? Like, where's Starship up to?
That honestly depends on who you ask. Obviously, we all know that SpaceX is run by Elon Musk. As far as what happens, his timeline is humans on Mars in about 10 years' time. Whether or not it pans out that way, some of his other timelines, they've been extended by a few years. So it's taken a few years longer to get to each point than we expect. Current estimates from them say that they think they will do a Starship test launch in the next month or so, if everything goes well. Now, we're about a third of the way through March at the moment, and that's still in question. Nevertheless, you have to remember that this is a piece of technology that's basically never existed before in the history of our species. It's still being perfected, and once again, we come back to the thing of, do you want to launch too soon and have the thing blow up? Now, it's one thing if you're launching a small rocket designed to deliver 1.5 tons to orbit. It's an entire another animal if you're talking about something that can lift 150 tons to low Earth orbit. We're talking about a situation where if that came back down on the pad almost fully fueled, you'd be talking about one of the largest non-nuclear explosions in the planet's history.
Right, so you definitely don't want that to go wrong.
No, and so rightfully so, they're being very, very careful about the way they go about this.
Very good. But you said, just then within a month or two, even if it's 6 months, we're still talking about Starship launching soon.
Yes, if you'd asked me 10 years ago whether I thought the possibilities as far as long-term human space exploration in the next few decades, where they were at, I would not have thought that Mars within the next 10 to 15 years is on the table. But here we are now, and that's looking very, very realistic. It's worth noting that the last time human beings went to the moon was 1972. It's been more than 50 years since any human beings have been beyond low Earth orbit. There's been a massive pause. An entire generation of people have they've been born, they've grown up, they've had kids of their own, and they've not seen real true space exploration. And now we're looking at entering a new phase where suddenly that becomes realistic again. And if you are listening and you haven't heard of these things, just take a moment to really think about that. You might be around at a time where once again, humans are setting out across the void, doing completely unprecedented things. It's often been said that part of our situation at the moment, because we've all explored the planet now, is we are out of frontiers, but I don't think that's correct at all. We are just at the beginning of a new one, and this could be some of the most exciting few years that anyone's ever witnessed. We don't know. Obviously, I'm very hopeful. Things could go wrong. It's going to be dangerous. Things probably will go wrong. But overall, it's a very, very exciting time for anyone who's even remotely interested in the possibilities that exist out there in the universe.
A question for you, Damon. What is your response, given that you're very passionate about this exploration to Mars? What do you say to people who say that we should be focusing all of our effort on fixing the problems here on Earth instead of looking at Mars and travelling out there?
This has been something that it's an issue that's been raised since the dawn of space exploration because, let's be honest about it, space exploration is very, very expensive. But relatively speaking, in the overall scheme of things, it's not that expensive compared to a lot of the other expenditures of government. But you also have to think about it in terms of its flow-on effects. So often when people talk about the Apollo program, they'll cite things like that came out of it, maybe vacuum cleaners or Velcro. What really came out of the Apollo program was the inspiration that it passed on to the next generation of people. The people who were children when the Apollo program was taking place, they're the people that went on to start Silicon Valley, to create a complete revolution in the way computers work. They're people that went on to create a complete revolution in medicine, in the way we treat people struggling with some of the most serious illnesses on the planet. These are people who were inspired to follow a path. Now, ultimately, for many of them, that path was not into space, but it turned their brains towards something in the sciences. And from there, they found their own way to their own passion. It's something we call intellectual capital. It's something inspiring to the next generation. You know, a lot of the time when we're educating about science, we're talking about very real, very serious issues, be them environmental, sometimes societal, disease, all those sorts of things. They're very serious problems and ones that we have to be aware of. But we also need something to aim for, something uplifting and inspiring. Since the dawn of time, humans have always tried to branch out of where they start. They tried to go further, find out what exists beyond the next hill, what's out there. And to some extent, when we look up and try to go to space, it raises our horizons. You know, often on Earth, we think we have a limited amount of resources, that we can't share everything. But up in space, there is an infinite amount of space. There is an infinite amount of resources. If we can develop the technology that can get us up there, who knows what could happen?
Right. So you're saying it's to focus entirely on a mission to Mars and its expense is losing sight of the bigger picture. And that bigger picture is the flow-on effects, the inspiration, the technologies that go into that mission to Mars, even if the vast majority of people aren't going to be stepping foot on Mars.
It's often said that when humans flew to the moon, what we really learned about was the Earth, because you had the pictures that came back that showed our entire planet as just a small sphere suspended in space. It created a paradigm shift in the psychology of our species, the way we looked at where we are and who we are. And that was just to the moon. If people go to Mars, they're going to be going into a situation where the Earth becomes a tiny speck, a tiny star, indistinguishable from all the others. We're going to have to look at things completely differently, but at the same time, we're going to develop the technologies, the approaches needed to pioneer entirely new worlds. And in doing so, we're probably going to find answers to some of the biggest questions. And we're also going to need to learn how to do things like treat people in new situations. All of these things are going to have flow-on effects for computing. For medicine, they're the obvious ones. For technology going further, how do we make food? How do we treat people in different situations? There are all these challenges which ultimately are probably not going to be addressed until we're actually facing them. It's all good and well to say, oh, we need to wait until either everything is perfect on Earth to go further, or until we have all these problems solved. But if you look in human history, that's almost never how things are done. We have to keep moving forward. We have to walk and chew gum at the same time. And I think ultimately that's the best way. And the other thing is, as we all know, if the money wasn't spent on space exploration, that doesn't necessarily mean it would be spent solving the problems that we currently have.
Yes, that's a good point.
Space exploration is just one way of many ways of keeping things moving forward and inspiring the next generation to really think big, very, very big.
That's a wonderful sentiment to finish on. Well, Damon, thank you for your expertise. I think you've given our audience a lot to think about.
Thank you very much.
Please Look Up is brought to you by Particle, powered by Scitech. We'll see you next month for a tour of the April night sky. Bye for now.